Okay, hi guys. So in this lecture, we'll be continuing on seeing the examples of Friedal craft alkylation. Okay, so let's get started. So the first example for this reaction is obviously we have something like this. Let's suppose benzene is given to us in excess amounts, and we have CS3 CHCl3 in presence of AlCl3. Okay, so first one Cl will be attacking on AlCl3 to convert itself into AlCl2 and positively charged carbocation, and in this case we would get something like, and on this benzene would attack and we will get something like this CHCl2. Again AlCl3 will come into the picture. Okay, and we'll get something like this as our compound, CH plus and Cl. As we have benzene in excess, we will get something like, on the top of this compound we will get another benzene ring attached to it. Again we will have AlCl3. The presence of AlCl3, we will have CH and phenyl rings attached to it. As we have this in excess, we will get something like PH, CH, PH, and 3 phenyl rings are attached to this carbon atom. Okay, so I hope you followed this example. Okay, let's look at another example. We have something like this benzene ring plus we have 3-member epoxide in presence of acidic medium. 3-member epoxide ring is unstable in all medium. We have seen this in previous lectures also because of high ring strain. Okay, this 3-member ring is highly unstable. So what actually happens is this O actually attacks on H plus to get converted into OH, and this gets a positively charged carbocation. This benzene ring actually attacks on this carbocation hence formed, and we'll get something like this as our compound. Okay, let's look at another example wherein we have something like this, and okay, let's twist this example a little bit. You have been given this as a product, okay, and you have to actually make this product by using Friedal craft alkylation methods. Okay, so what are the different ways in which you can build this or make this compound? So the first method could be you can have a benzene ring and you have this reagent in presence of AlCl3, you will get this compound. Second could be you have this benzene ring and you have this as OH in presence of H plus, some heating may be required, you will get this product. Okay, so are these the only two methods? No, there can be many, or there can be something else also. So we can actually have something like this as well. In presence of H plus, we'll get this compound because the central middle carbon atom will get the positive charge. Fourth way could be we can have also something like this. In presence of H plus, some heating may be required, we'll get a positive charge here, but because of rearrangement we can get positive charge on this carbon atom after the H minus shift. Benzene ring can attack on this. Now, is this the exhaustive list? No, we can also have something like Cl in presence of AlCl3. Okay, again this would be the carbocation formed, but the carbocation as soon as it's formed undergoes rearrangement. Okay, and H minus shift actually happens. Okay, so As far as the present understanding is concerned, these are all the various ways in which you can make this compound. Okay, so let us now talk about this example. Let's continue our series of examples. So we have something like this, presence of AlCl3. What would be the compound formed? We would get something like, first we will get carbocation formed here. Next we'll get 1 2 3 4 5 6. There is a chance of 6-member ring formation. Okay, if this carbon atom actually attacks on this nucleophile, so 6-member ring can be formed if this carbon can attack on this carbocation. Okay, so we have, this is the first carbon, 2 3 4 5 and 6 is this one. So we can form compound like this. Okay, on the same lines, let's see what actually happens in this example. We have something like this. Okay, so what actually happens in presence of AlCl3? So we would get something like this, positive charge here and Cl here. Okay, so let's say what else we can do about it. We would have something like, again the benzene ring would be attaching the carbocation. One, two, 1 2 3 4 3 4. Okay, and again Cl is there in this formed compound. Again in presence of AlCl3 we would have a positive charge here. 1 2 3 4 5 and 6-member ring can be formed. Okay, with 2 substituents attached here. Okay, let us look at the last example for this video lecture. We will have something like a benzene ring and some compound like this, and we are passing it in presence of H plus and heating it. Okay, this is the ether. Alcohols and ethers are stable in basic medium, not in acidic medium, hence it will undergo reaction, and we will get something like OH here and positive charge here. Okay, again benzene will attack on this positively charged carbocation, okay, to form something like this compound. 1 2 3 4 1 2 3 4 OH here. Again in presence of acidic medium, what we'll get is, again this OH will attack on this OH will attack on this H plus and will get a positive charge here. Again in presence of acidic medium, so we'll get something like this because of electrophilic aromatic substitution reaction. This is the final product formed. Okay, so with this we come to an end of this lecture. In the next lecture we'll be seeing drawbacks of Friedal-Crafts alkylation reaction. Okay, till then, good luck and goodbye.